Okay, good morning, everyone. Let me get rid of this. There we go. All right, so today we're going to start chapter 2. We skipped chapter 1 in the text because I feel like it's a lot of stuff that we covered in 8th grade. We've gone over it before. You go over it every year in science, and we want to get into some of the chemistry stuff. So we're going to go ahead and start in chapter 2. You should have already taken the vocabulary notes from the book. You could have either looked them up in the back or looked through them throughout the chapter. We'll be starting on page 45, classifying matter, and we'll start with section 1 today. Okay. You can feel free to take notes however you like. If you want to just watch and answer the questions throughout the Edpuzzle, that's fine too. However you feel that you are going to learn best is how I want you to take notes. Okay, so anyway, chapter 2, section 1, classifying matter. Our key ideas are how are matter going to be classified, how are elements and compounds, or how are elements related to compounds, and what is the difference between a pure substance and a mixture. Okay, so let's just start off by talking about what is matter. Matter is anything that has mass and takes up space. Okay, and then every sample of matter is going to either be an element, a compound, or a mixture. And then there's two types of mixtures that we'll get into. Okay, so you should know what an element is, a compound, and a mixture are, but we're going to go over them here again. And hopefully, if you had any confusion, I'll be able to clear those up while you watch the video. Okay, so matter, anything that has mass and takes up space. The first category of matter is going to be our elements, and elements are substances that cannot be broken down into simpler substances. These are organized on our periodic table. Okay, that's an important thing to know. So on our periodic table, remember there are 118 different elements. Okay. These are made up of atoms, and atoms here, and here's a definition. So atoms are the smallest unit of, I guess I should say, an element that keeps the element's chemical properties. Okay, so atoms are the smallest unit of an element. I have to fix that. That keeps the element's chemical properties. So even though we have, let's say we have aluminum. Aluminum's an element, you learned the symbol of it. Say we have a big sheet of aluminum foil. It all has physical properties. So like something like shiny, malleable, you can bend it and mold it. Think about one atom still having the same chemical properties. So those ones that I listed were physical. One atom, sometimes you can't really tell whether it's malleable or not because it's so small. But think about the chemical properties of aluminum, how it reacts with another chemical, how it reacts with an acid. One atom will react the same way that that big sheet of aluminum will. Each different element is made up of one unique type of atom. Okay, and when I mean type of atom, I mean differences in protons, neutrons, and electrons. Now, if you remember to 8th grade or even biology, you talked about protons, neutrons, and electrons. One of them is positive. Which one? One of them is negative, and one of them is neutral. Okay, protons, think protons positive, neutrons, that kind of looks like the word neutral, and then electrons are going to be our negative ones. Okay, and depending on how many protons, electrons, neutrons that the element has, will give it its properties and how it reacts with different things. So that's how we have different elements, is based on these numbers of protons, neutrons, and electrons. Okay, all right, let me erase this and we'll go to the next slide. All right, element symbols is something that you should be pretty familiar with. You should have just taken a test on them. And elements are represented by these symbols on the periodic table. And when we start to form compounds and things like that, we're going to be looking at these symbols. Okay, so it's important that we know and are able to understand what scientists mean when they write these symbols. Instead of writing out the whole word, we need to know what they are. So they're just the first letter capitalized always. The second letter will always be lowercase if it has a second letter. So Al, remember aluminum, capital A, lowercase l, capital C, lowercase a for calcium. Then we have chlorine, carbon, and oxygen listed there. And you should be familiar with those. If you're still a little concerned that you don't know them, make sure that you continue to practice those. When you look at them on a periodic table, and you'll be getting one of those shortly if you haven't gotten one already, you'll see that they have these symbol here, or like a number here and a number here. This is your atomic number, which is the number of protons that atom has. And here, this is your mass number, which is your protons plus your neutrons, okay, because they're going to be making up a majority of the mass. So you'll notice that in the periodic table, each element has a different number. So that means that each one has a different number of protons, and that's what I meant by different atoms, okay? These different numbers signify different types of atoms, okay, because they have a different number of protons. All right, so atomic number, you'll want to know that, and you'll want to know the mass number. You want to know that it's protons and neutrons, okay? All right. On to the next one. So molecules. So when we talk about atom, we usually just mean one individual like atom. So a nucleus with electrons on the outside. So when we talk about an atom, we have this nucleus, and then around the outside, we have these little electrons. That would be one atom, okay? When we talk about a molecule, we mean two or more. So two or more atoms combined. And they can be the same type of atom, so they can be two oxygen atoms together. That makes a molecule. Or we could have a carbon and an oxygen molecule together, and that would also make a molecule, okay? When they're the same type, that's going to be an element, okay? So two or more oxygen atoms together making a molecule, that's going to be considered an element. If we have two or more different types of atoms, or different types of atoms together, so a carbon and an oxygen, that's going to be our compound, okay? So if I had to draw these out, an element, so let's say one red dot is one oxygen atom. I can have two oxygen atoms together. That makes a molecule, but that would be signified as an element, okay? I could also have a compound, so let's say our oxygen molecule with a carbon molecule, okay? So the dots are different. We have one carbon, one oxygen. They're chemically combined, forming a molecule, okay? You can think about this like letters in our alphabet. So we have 26 letters in the alphabet, and we can make tons of different words with those letters. We have 118 different elements, and think about the number of combinations you can make with that. So there's tons of millions of different types of molecules that you can look at. Okay, so let's see. So speaking of those combinations, what those are specifically called, and we talked about them a little bit on the last slide, but here's a slide all about compounds, are substances that are made up of two or more different types of atoms. So like the oxygen and the carbon, okay, that would be a compound. This individual thing is the whole thing together is a molecule. But because they're chemically combined, that's important. Chemically combined, that's going to make them a compound. So compounds are represented by chemical formulas. So this example, everybody should know what H2O is. It's water, okay? What it's saying is that you have two hydrogen molecules for every one oxygen molecule. So if this is our oxygen, we'd have two hydrogen, okay? NaCl, that would be a sodium and a chlorine chemically combined together, making up your molecule or your compound, okay? Chemical formulas show how many atoms of each element make up the molecule of the compound. So here, because of the two, we had two hydrogens. And because there was no number here, that's always assumed to be one, and that's one oxygen. And then compounds have their own unique properties different from the elements that make them up. So water does not have just the properties of oxygen or just the properties of hydrogen. It has its own new properties that it makes when those chemically combine. Okay? So that's a compound. Oops. Okay, so pure substances and mixtures then. Pure substances are matter that has a fixed composition and definite properties. So elements and compounds are both pure substances. You want to make sure you know that. So elements and compounds are pure substances. Why is that? Well, if let's just say I have a little container here. Here's my container, and here's another container. And if I have an element, okay, I have a container full of elements, okay? If I randomly pick out of that container any one of those things, they're all going to be red dots, right? And it's always going to be the same. It's a fixed composition. But if I have a compound over here, so we'll have the same of those everywhere. They're chemically combined. Remember, we could say this is carbon monoxide, one carbon with one oxygen. Anytime I pull something out of there, it's going to be this whole piece. It's the same composition. So no matter what I pull out of there, it's going to be the same for both elements and compounds. Okay? Same composition. So no matter what you're pulling out of that bag, it's going to be the same. However, mixtures are not pure substances because they do not have a fixed composition. So mixtures could be a combination of elements. Okay? So I have this element here and I have this element. If I pull something out of that bag, I could get this one or this one. The composition is not the same. I'm not going to get the same thing every time. So this is an impure thing. So this is a mixture. And you can have mixtures of elements. You can have mixtures of compounds. Okay, so two different compounds together. Or you can have a mixture of elements and compounds. And any of these, you are not going to get the same thing every time you pick something out of the container. Okay, and that's what makes it a mixture. It does not have a fixed composition or definite properties. So when I pull this red one out of here, it's going to have different properties than this one. And when I pull this compound out of here, it's going to have different properties than this one because each compound and each element have their own unique characteristics and properties. So if you just happen to mix them all together in a container, you're not going to get the same thing and they're going to have different properties. So like sugar and sand. Sugar's going to dissolve, sand's going to sink to the bottom. That's a mixture. Whereas an element, something like aluminum, it's going to be the same no matter what, the whole way across. It's not going to be different. It's going to have the same property the whole way. And then compound, something like table salt, NaCl, same composition the whole way through. Okay, so elements and compounds are pure. You need to make sure you know that. And mixtures are not pure because of the differing in compositions. Okay? All right. Almost done. A couple more slides. So how are mixtures classified? So we know that mixtures can be any combination of elements, compounds, or a combination of both elements and compounds together. And we can classify them two ways. The first way is a heterogeneous mixture. And look at that first part, hetero. Okay? Hetero means different. Okay? So components are not evenly distributed throughout the mixture. So I think of something like a salad or pizza. I can see the tomatoes in the salad. I can see the carrots in the salad. I can see the lettuce. I could pull out all of those different pieces. It's not really organized. You could also think about like like sand and water mixed together. You could think oil and water. All of those things would separate and you could see the different components. However, when we think of homogeneous, look at specifically the homo part. Homo means same, and components are evenly distributed throughout the mixture. So we can't really see the different parts. So if you think of apple juice, can you see the sugar? Can you see the whatever else is in apple juice? Okay, no, it all looks exactly the same. Same thing for like Kool-Aid or Jello. It looks the same throughout. It's not all one element, it's not all one compound, it's a mixture of a bunch of different things, but we can't see the different parts. Okay? Homogeneous mixtures, and you want to make sure you note this down, can also be called solutions. So AKA, also known as solutions. Okay, make sure you know that. So these two words can be used interchangeably, solution and homogeneous mixture. Okay? All right, so those are our two types. Heterogeneous, you can see the different parts. homogeneous, look the same. You can't see the different parts. It all looks even. Okay? All right. Last slide here. All right. Mixtures do not just have to be liquids with liquids. So we think like water and oil, which would be an example of liquids with liquids. We can also have a mixture of metals, which are two solids. So if we take zinc and copper and mix them together, we get brass. And that's called an alloy. Okay? And we can also have gases mixed to a liquid. So something like a carbonated drink. So we would have your liquid, and then you would have like the CO2 that makes your carbonation. Okay? An alloy or mixture of metals would be solid with a solid, right? I guess I didn't write that. So you can have solid-solid mixtures, liquid-liquid mixtures. You could have liquid-solid mixtures, so like sand and water. It doesn't just have to be liquids and liquids. There's tons of different mixtures, and some of them, like brass, we don't even really think as a mixture. We just look at it like, oh, that's a metal, yeah. But no, it's zinc and copper physically combined together. One more thing I want to add before I let you go today is how we separate mixtures versus compounds. So compounds are combined how? Physically or chemically? Chemically. Whereas mixtures are combined how? Physically. They can easily be taken apart. So compounds, to separate them, you need a chemical change. To separate. Whereas mixtures, you can separate physically. Except for you're not going to be able to see the whole rest of my physically part. Okay? All right. So with that, I'm going to let you go. Make sure if you have any confusion or confused in any way, make sure you read the text. Again, it would be page 45 through 50. Okay? And I'm going to have some questions here at the end of the Ed Puzzle for you to answer, and then that will count for your assignment today. Let me know if you have any questions. I will see you all back in school on Monday. Okay? Have a great weekend. I will see you guys soon. Bye.